This video is brought to you by Squarespace, but more about that later. Hey everybody, what we're going to be doing in this tutorial is making dandelions procedurally. We're going to be making kind of like the seed blowing animation. You get the idea. Let's start the tutorial. And the first thing I want to do is I want to take the stem and have it kind of like sway back and forth. I'm going to use a curved line as the base mesh, add some geometry to this. I'm just going to offset it with a set position relative to the spline parameter. And now you can see we have a fully procedural kind of shape of the stem. Of course, this needs to change over time. And the idea I want to go for is we're going to set position relative to where each point is on the x-axis. So if it's very far away, we're going to give it a nudge towards the center. And let's use like -0.1. Let's see if this works. And obviously the thing that this is missing here is that it doesn't like overshoot. So we're going to need to take a more physicsy velocity approach. So I'm going to use a named attribute, v for velocity. What we can do is we can update this vector. So I'm just going to plug that in right there by this term that we made before. Clearly this isn't doing anything, and that's because the velocity isn't told to do anything. So just use a set position and connect this right here, and you can see all of a sudden this is swaying, but it's gonna go on forever. Scale it on every frame by something like 0.9, so now it's actually dampening super quickly. And instead of this kind of starting off in this position, I want it to start upright, which means we need to have a force that initially acts on it. So no need for all this like set position stuff. We can take the spline parameter, which tells us how far up the curve we're going, make this also a function of x, and just add that to the initial velocity, which will kind of make this extend until like the elasticity brings it back. Say only apply this force for frame greater than 5 and also frame less than 10, let's say. Multiply these together and make that the condition. But it kind of looks shitty. It's too strong and it doesn't have any bend to it. Just kind of curve that. And now you can see it's kind of doing more of a bendy type motion. Multiply this by a number smaller than 1. Look at that. It just miraculously works. And I want you to think of this as basically the operation for bending the stem. When I play this, there's actually something wrong going on here. The stem is actually longer than it would have been if it was standing up straight. We can use the trim curve function. We say that the length has to be preserved at 5 units. You might not be able to tell the difference, but instead of kind of bending all the way up here, this has actually gone down a little. I took this curve and instanced a bunch of spheres on it, but when we play this, you can see that as it bends outwards, the gap between these kind of spheres or pearls is inconsistent. So there's kind of like a stretching going on here. And there's actually a cool new node that solves this. It's called redistribute points on curve. You take this and drop it in here. The gap is now constant. Curve to mesh. And this is our procedural node simulation of the stem. Now to the good part. I want to add a sphere right here that the seeds are kind of coming out of. And I want to use this UV sphere to approximate that. So join these together. Just going to transform this so it's sitting correctly. Scale it down on the Z-axis. And of course, this doesn't connect. So instead of the join geometry, we are going to instance on points relative to the original curve. We create a endpoint selection node and say that it's only at one of the endpoints. I guess it's for the other one. And it is connected now, but it's not orienting correctly. So here it should be facing this way. A frame prior, it should be facing that way. And the theory for how I want to solve this is I want to take the last 2 points of the curves and we draw a vector between them. And that's going to kind of show the direction that this should be oriented in. First one is index 49, because remember the indexing starts at 0 and there's 50 of them. And the other one is one before. We want the difference between them. We're going to use align Euler to vector. And of course, we want this to be the rotation of the instance, which almost works, but you can see it's kind of like a bit glitchy. This needs to be set to Z. I think it looks pretty good for our purposes. Here's the node graph. And now to switch gears, we need to make the actual seeds. I'm going to start off with the UV sphere, transform this so it's in the shape of a very small seed. We're going to add in a bit of surface noise. Of course, we also need the feather part of it. So I'm going to take a curved line. I'm going to join this with a couple more curved lines to kind of act as the propeller. So we're actually going to use a points node so we can make a arbitrary number of these. Connect curved line to instance on points. I'm going to rotate it on the y-axis by 90 degrees. And if we add more points, we expect there to be more propeller blades, but they're overlapping so we can't see them. You're going to take a random vector and connect that to the rotation. I'm going to max this out on the z-axis, increase the count to like 25 or whatever feels right to you. We're going to use another random value as the scale. You can say go from like 0.3 to, let's say, 0.6. So I'm going to use the translate instances with more Z, but I guess this can't be in local space, so just kind of put it on the top, join them together. Curve to mesh, resolution can be tiny, and this doesn't look half bad. Final details is we're going to transform this back down. Now when we rotate it, it's kind of like on the correct hinge. It's moving how it should. Add a realize instances so that this is all nice geometry. Think of this as basically the seed with the propeller, and now we have kind of the framework to make the animation, finally. This is what we want to add seeds to. Distribute points on faces, gonna bring up the density. So you can see we get this kind of weird looking situation. First things first is we're gonna take the scale and kind of bring it down. This is already looking much more sensical. Take the rotation and connect it to itself so that these are now pointing like outwards. You can see that the seeds are kind of inside of this because we made the propeller kind of the pivot point. So I'm just gonna use a set position to move the points, and I'm gonna offset by the normal, which you can see does nothing. But that's because the sphere itself is an instance, if you remember from before. All of a sudden, our seeds kind of go everywhere. I'm gonna use the vector math to kind of scale these in, and let's kind of bump up the densities. We want this to look a bit more random, where some of these are tiny and some of them are big, and you might think that this is easy to do, but it's not. Because if we take a random value and connect that to the scale, we have this issue where some of the seeds kind of reach the pistil, and some of them don't even get close. And again, that's kind of a pivot issue, and that something different is actually connecting it here from 0.16 to, let's say, 0.3. We're gonna actually map range these, where we go from 0.16 and 0.3 from before. I'm gonna connect the scale so we can see what we're doing, and then the name of the game is basically playing with these values, and the last step is gonna be to actually blow these away in the wind. You see, when I play this, we have the animation we made so far, but the moment I add in a simulation zone, now it's actually stationary, no matter how many times I play this. And this is because this entire node network is fed into the simulation zone, which is then kind of like self-referentially looping, which means that it's stuck on the same frame forever. So what I was trying to figure out is a way to kind of like circumvent that, and I think I came up with something. I'm gonna move all this stuff to the side, so we're just dealing with the point distribution, and this is what I'm gonna feed through the simulation zone. I'm gonna add in a node that's just gonna make it easier to see what we're doing. So now you can see this very fine distribution of points. This isn't moving at all. The clever thing we can do to actually bring this information over, we're gonna look at this geometry. Remember, this is the one that actually moves. Sample this geometry looking at the index. What is the position of this? And I can bring this information inside the simulation zone, which now actually transfers the position of these. I'm gonna take this selection and filter it through a random value. So you can see some of them are kind of left behind. Add another set position where, let's say, this is now affected by gravity. Take the inverse of this, have the set position work for this. You can see that some of the points are falling and other ones are actually like inheriting the motion. And obviously I want these to move kind of relative to the direction we're blowing them in. So I'm gonna add a random vector, making sure the X goes from 0 to 1 and everything else can be 0 for now. The points are moving, but obviously a bit too quickly. This can be 0.1 divided by 2, and now our motion is less intense, but let's make it look better. Negative 0.01 on the Y and Z, and then a symmetric 0.01 for here. And now these are kind of distributing more in a scattering way. And I want these to actually be blown away based on a certain rule. And that rule is going to say that points near here are going to blow before points near here. I just want to snag the position of these so we can reference them later. We're going to call it POS for position, not for piece of shit. Connect the position field to that. Separate by XYZ, and I care where this is greater than or less than some value. So for now, I'm just going to kind of swap in this input so we can see what we're doing. When this is set to 0, we're looking at which points have an X component greater than 0, and these are the points that are going to kind of like stick on and everything else is going to move. And as we make this more negative, you can see it's kind of sweeping our points. I'm going to make it kind of like the most negative it can be. Keyframe this, and then maybe a couple more frames down, we have this go up to, let's say, 0.2. And now these are being blown in a pattern that looks a bit more believable. There should be some points like this one and this one and this one that don't actually move with the wind. We can incorporate this by adding our random boolean. And now just kind of like a final detail, I want some points to still be able to be blown away, but just like slightly after. Keyframe this probability, go a couple more frames down, make it smaller, and then for the keyframe, I'm just gonna move it a couple frames down. So with the initial gust of wind, we lose most of our seeds, but then as time progresses, you can see a few more just kind of like our stragglers here. I'm just gonna take our instance on points and then take the seed from before, which is gonna look wrong, store that rotation from before so we can actually bring it into the future. I'm gonna call it ROT. Connect this rotation. We're gonna use a named attribute, and I basically did the same thing with the scaling from before, before, where we have random values and then also offset these on the normals. So Shift P to make that its own group. Okay, so I played around and just modified stuff a bit to look a bit better. The only thing missing is that once these seeds are shot out, there's no rotation, right? So I'm gonna take a rotate instances node, which is going to let us rotate our instances. We only want to do it for the ones that have kind of come off. So I'm gonna use this store named attribute, take our selection and plug it in there. And if we take a named attribute called off, math node, flip it, subtraction, 1 minus. We play this, some of them are off, and when I rotate them, yes, only some of the selection is doing it. So let's just randomize it, why not? I'm gonna normalize it. We're gonna scale it by time so that this evolves over time. Yes, I could have done this in Simulation Zone, but whatever. But I don't want all of them to be the same, so I'm gonna multiply them by random value. And this is basically our final animation. Let's make this thing shorter, and yep, still works. Let's make the simulation more violent. Yep. So I added a few inconsistencies here, and now when I play this, the stem doesn't look so rigid anymore. You can download this file on Patreon so you can actually have this and play around with it. Look at those beautiful dandelions. I'm proud of them. I don't know if you were able to follow this tutorial. Anyways, this tutorial has been sponsored by Squarespace. It's the best and the easiest platform to build a website on. You just drag around blocks instead of this non-intuitive coding mumbo jumbo. 3 things you gotta know about Squarespace. The first is that you can see who's going to your website, and that's analytics, demographic type information. The second one is that they have a nice content library that I see akin to like Google Drive. It's basically like all your files that you've used on your website stored in one place. And thirdly, like I said, you can move around blocks, okay? Video block, text block, just position them. So go to Squarespace and make yourself a website, and when you are ready to take that thing live, you can use my link in the description to save 10% off. What? Your first purchase of a website or domain.